Okay, so good morning, good afternoon, good evening to all of you, and thanks for joining March webinar. The topic for today is the ETSI NFV, exploring ETSI NFV releases 4 and 5. Why did I choose this topic? First of all, I saw that many requests from many colleagues to explore that particular area, because the concept of standardization, it exists in telco and telecom in general, but it looks a little bit, I would say, new for the colleagues who are coming from software and cloud background. So it's important to explore what is the concept of standardization and what is the contribution of ETSI NFV in the domain of the cloud in general, at the telco domain. Also, because with the technology evolution, there are many variables along the way. So it's important to assess if still ETSI NFV still contributing, still committing to provide standardization and references for the technology evolution, such as like 5G, Open RAN, and even the evolution in the cloud itself, like going from virtualization to containerization. So basically, this is the goal of the webinar. I hope it satisfies your it will satisfy your expectations. And just so quickly, that's like an overview about my profile for the colleagues who are attending like for the first time. So my background is purely from Telco, but in multiple domains, like in OSS, mobility, data networks. So I'm basically a core consultant. So I'm coming from a core background, a mobile core background. But starting from 2015, I started to have more exposure and more experience in the fields of cloud, orchestration and automation, and I exchanged seats in many entities like vendors, software providers, system integrators, and also mobile operators. I'm frequently doing webinars and content online for the sake of knowledge transfer. And I have also some contribution in some standardization body than some open source initiatives. So I kind of see the technology from many angles, and this is how I shape my content. I try to make it always vendor agnostic and also fits to, I would say, to the audience from different backgrounds. Before I start and talking about the agenda, we will have like main like 3 sections or 4 sections. So I will leave the door open for questions after each section. Please use the Q&A utility. I'll try to answer the question throughout the webinar. If not, I usually take it and post it on LinkedIn in offline, like with like a Q&A. So today we are going to explore what is ETSI, what is ETSI NFV, and what is actually a reference architecture, because again, the concept might be there for the telco people, right? But a concept of reference architecture with this kind of drawings and interfaces and reference points might be something new for the colleagues coming from different backgrounds. So I'm going to explore that, and then I'm going to take you about the architecture evolution through the releases, and you'll see how ETSI NFV reference architecture now evolves to cater or to welcome other entities like multi-DC connectivity, like the containers orchestration tools and containers management tools. And then I will shed some light on some selected features on the release 4 and 5. And for sure, I'll explain what is the concept of release, and then we will end up with some key takeaways. So let's start. I commonly start all my webinars with some sort of a timeline, because I always feel that it is important to understand the evolution of a technology, the history of an entity, just to understand the background and how we reached our current state. And this is what I did in this webinar. So I just wrote a timeline about the ETSI. And ETSI stands for European Telecommunication Standards Institute. So ETSI is not something, it's not a new entity for the Telco tribe. So it was established in 1988, and somehow it took the duties and the functions of something called a CEPT, which is the Conference of the European Conference of Postal and Telecommunication. And just right after the establishment, ETSI took the ownership of the GSM of the 2G specs. So we people working on the telco, we know that ETSI is the standardization body of the 2G of the GSM. And then in 1998, ETSI was one of the founding partners of the 3GPP, and 3GPP actually, that's I would say, the main source of standardization for the mobile telecommunication. So anyone working on the RAN, on the core, on the IMS, even on the VAS, 3GPP has been always and still the sole reference for standards in the mobile industry. The time goes on, and also, yeah, ETSI had the contribution of the first 3G specs on 2002, which is the UMTS. And similarly, in 2009, with the first LTE release, ETSI has a major contribution in the LTE. So you see where it is coming from. So that's the home of mobile communication standardization, and actually standards for other domains, but mainly ETSI is the main standardization provider for mobile telecommunication or mobile industry. That's why in 2012, when the initiative of NFV came from the mobile operators in October 2012, when they issued the white paper, the well-known white paper in the SDN Open Flow World Congress in Germany, just right the months after October, November, ETSI was chosen to be the home of NFV standardization. So you know now, understand the logic why ETSI NFV or the ETSI itself is the home of NFV standardization. And then the effort, I mean, the progress is still going on, and into 2019, the release of 5G also had a big contribution from ETSI as one of the organizational partners of 3GPP. So that's ETSI history and contribution. And now we have a starting point in 2012 when ETSI has been chosen to be the home of NFV standardization. And now, starting from 2012, we have the ETSI NFV ISG, which is ETSI NFV Industry Specification Group. To understand the publications and the standards from ETSI NFV side, you have to understand the internal structure of the ETSI NFV. What are the working groups and what kind of standards they are providing? So currently there are 8 working groups in ETSI NFV. There are some other former working groups, but now they are closed. So I'll just mention the names and I'll give you an overview about what do they do. So we have the evolution ecosystem. We have the interface and architecture, commonly we say IFA, and we have the Network Operator Council, which is the NOC, which I worked with actually during like 2016, and reliability and availability and security and solutions, which commonly we always say SOL, and the Technical Steering Committee, TSC, and then one of the newly, it's not new, but relatively new compared to the others, which is Testing, Implementation, and Open Source Working Group, TST. So EVE, or Evolution Ecosystem, you will find always publications around the new use cases of NFV, the reports that try to assess new technologies and how can NFV contribute to. For example, you will find some documents about Open RAN, about 5G coming from EVE. The IFA, which is the most common, well-known working group, these are like usually the issue what we call stage 2 publications, and I will explain what is stage 2. And they provide like information models, they provide call flows, they provide like on a high level logic how the functional blocks should behave, what is the overall use case. The NOC, it's coming from the name, that's the Council of the Operators. Sometimes they do some validation, they do checks, they do recommendations. So that's the council gathering the operators, mobile operators or whatever operators. Reliability and availability, the issue publications related to the operational part of NFV. I mean, the operational part, for example, in new releases, they talk about the upgrades, for example. So that's the operational part. Security, for sure, this is the security part of the ETSI NFV, of the NFV. And then Sol Solutions, this is the working group that issues what we call stage 3, the bits and bytes, the API specs. So usually when an interface has a Sol, we are happy, because this means that interface has an API specification. They have like a base that suppliers or vendors can develop their applications to comply to or to adapt with. PSC, that's the responsible of the coordination between the working groups. And then the TST, this is the working group who issues like publications about how to verify stage threes, how to test the APIs, talking about performance metrics. So sometimes they call it stage 4, and which is actually not a common term in the formal standards body, but this is like how you test the interface, how you test the APIs, how you test the metrics. So it's all about testing. That's why you find vendors of testing vendors, like whoever doing testing is active in that working group. So if you go to ETSI NFV portal or ETSI NFV landing page, you will find the ETSI NFV architecture, and you will find some sort of mapping of these terms or working groups on the reference architecture. To help you interpret the standards, for example, if you see this reference architecture, regardless what is the reference architecture now, but if you take this functional block, which is VNFM, let me use the laser pointer. So the VNFM, for example, and the northbound of VNFM is the NFVO, NFV orchestrator. So if you see the interface between them, or let's say the reference point, it's called OR VNFM. That's the reference point, orchestrator VNFM. And if you see the related applications, you will find that IFA 007 and SOL 003. So if you are keen to understand what are the use cases and what are the operations happening between the VNFM and NFV and what kind of dialogue they are having, then you should go to IFA, okay, IFA 007. If you want to understand what are the exact APIs specs between the NFVO and the VNFM, then you go to SOL. And that's how you interpret the terminology of the publication. So if it's IFA, then it's stage 2. If it is SOL, then stage 3. And by the way, this is one of the classic interview questions when someone wants to check if someone have a good experience about ETSI NFV or architecture. They ask you, okay, what is the standardization of the ORVNFM? So you tell him IFA, and then you tell him SOL. Regardless if I'm okay with that kind of interview questions, but it's very common that you get this kind of questions. ETSI NFV or ETSI, following the concept of releases, which is very common practice from the standardization bodies. So from ETSI NFV, they work on 2 years phase, and they started in November 2012. So from 2013 and 14, that's what we call pre-standard studies, and that's a release 1. There was nothing really solid to act on. But starting from release 2, 2015, 2016, the architecture started to be clear, and even the adoption of the NFV started also to rise all over the world. So 2015, 2016, that's where most of the mobile operators start to embrace the new technology. And me personally, I explored that being one of the mobile operators and also exploring to deploy a Telco cloud based on NFV release 2. And then we have R3 2016-18, and then the most mature one, or the most, what I say, updated one, it's NFV release 4 that was closed in 2020. And ongoing currently, we have the NFV release 5. I'm going to take you through these slides through the webinar about the architecture evolution through these releases, and also some selected features from these releases. But that what I'm doing now is just the base to understand or to interpret the ETSI NFV publication. Usually, following the ITU standard, I would say framework, standardization are based on stages. So stage 1 is usually the idea. It's usually in form of report. It's usually about the requirements on a high level. And in ETSI NFV, you will find something called stage 01, which is actually the initial stage. So usually, if you want to develop a standard, you should first issue a stage 0, stage 1 report, or something that describe what is the use case and what are the requirements. Stage 2, and that's again the IFA thing. This is the architecture, the interfaces, the information flows, the call flows between the blocks, and somehow the information model. And then stage 3, this is actually the actual protocols. People working on 3GPP, if you tell them stage 3, then that the bits and bytes, you will go to the call flow of the mobile attach or mobile session, and then you understand every bit and byte, what does it mean. So here in ETSI NFV stage 3, it's not an exception. So it talks about the protocols and data models, the exact API specs, for example. And then stage 4, and this is something was new even for me, coming from telco background. This is actually the testing thing, how to test stage 3. So there are some publications you'll find in ETSI NFV that has the label stage 4, and this is referred to the TST testing working group. So with that thing, we reach, I would say, a good understanding about ETSI NFV, how do they work, what are the applications, how to interpret them. So if you have questions, please feel free now to drop it in the Q&A, and I will take it from there. We can have like a few minutes to explore the questions. So there is one question about what is the NFV release currently used now. So currently, most of the specs, most of the integrations are happening using R3, R4. So we are between R3 and 4. I'm talking about the adoption of the telco in the telco cloud. So it's usually R3 and R4, commonly R3. Any other questions? Okay. So now let's assess the architecture. Okay, what is the evolution in the architecture through the releases? Okay, so with ETSI NFV release 1 and 2, we had this very famous reference architecture, the ETSI NFV reference architecture. And that reference architecture, we're talking about having like a cloud stack, but from a telco perspective, like it has like hardware resources, virtualization layer, which is the hypervisor, and then that hypervisor abstracts the physical resources and provide that to the network functions in terms of virtual resources. And the totality of this domain is called NFVI. And NFVI is hosting VNFs, which is the virtual network function, okay, that's based mainly on virtual machines. And that VNFs is connected classically to the EMS, the element management, and that element management northbound connected to the OSS, BSS, which is a classic integration in the telco. And to manage that stack, we, or ETSI NFV, proposed the MANO, the NFV management and orchestration framework that consists of a VIM, virtualized infrastructure manager, that maps to solutions like OpenStack or VMware before they go to OpenStack as a VIO. So those were the solutions. And the VNF manager is actually the entity who's handling the lifecycle management of the VNF, like scaling, healing, and these kinds of things. And usually in the first wave, it comes with the VNF vendor. And the NFVO, or that's the orchestrator of the NFV domain, that doing network service orchestration and resource orchestration across the NFVI. And there were some repositories like service and VNF descriptors and VNF catalog and whatever. So let's first explain what is a reference architecture and what is the need of a reference architecture. So we, people working on telco, the telco community is very used to get a reference architecture. For example, 2G, 3G, 4G, IMS, CS, whatever technology or specifications, standardization in 3GPP, it must have a reference architecture. The reference architecture, the operator takes it and then enforce it into the vendors, asking them to comply to a reference architecture. For example, if you have a multi-vendor integration, you can, for example, get a VNF manager from vendor X and NFVO from vendor Y, and then me as a customer or as an operator, I give them the reference architecture and the corresponding standardization, and I tell the vendors, you have to follow these standards, and most probably these vendors are following the standard. So a reference architecture is a very good basis to start with. That's the starting point for any new technology adopted by a mobile operator. Plus, the mobile operator, they use the reference architecture to shape their organization. So if you see a reference architecture of a core or IMS or the combination of radio core and IMS, you will always find that the functional teams are divided by scope mapped to a reference architecture. That's why when the ETSI NFV came into into live, they haven't started with a service-based architecture, like somehow the way we draw software components and these kind of things in cloud or software industry. They came with a reference architecture. And that reference architecture was a little bit complex, as you see, and somehow has very defined interfaces. For example, if someone tells you, can we integrate the VNF manager to the OS BSS? You will always have two answers. The classic answers, which is 100% no, because reference architecture doesn't say that. But the modern answer or the agile answer is actually, if the VNF manager is exposing a certain service or a certain capability that OSS can consume for a specific use case, then yes, why not? That's the modern way of thinking. And that's actually what we want to reach. I mean, switching from the telco mindset, classic mindset, into the agile software mindset. So that was the start in 2014 in NFV release 1 and 2. The remarkable change in the architecture came in NFV release 4. And in NFV release 4, they provided, or they introduced the concept of WIM, which actually WAN Infrastructure Manager. And that was somehow a gap in release 3 and 2 was identified when you need, for example, to configure a multi-site connectivity. For example, you have a data center, and you have an OpenStack here and OpenStack there, for example. So you can cleverly configure the intra data center networking with a DC SDN or with OpenStack. You can do that in both sides. But when it comes to the connectivity between the two sites, for example, for a certain service that spans across the two DCs, or a certain service that needs communication between two components in two data centers, you need something to do this configuration. So usually that was a gap, because NFVO or the Vim capability didn't include doing configuration of intersite. So they introduced the concept of the WIM, but then they brought two options, and the WIM here is, think of it as a data center controller that had the capability to do a multi-site connectivity. So they had two ideas, that either the NFVO can communicate with that entity and push that information, and then that DC controller can configure the one part of the NFVI or the data center interconnectivity, or that can come from the OS SBSS. For example, the domain orchestrator or the service orchestrator can communicate to that controller, and then controller talks to the networking part. And you see here, they have the two options, like having the WIM part of the mono, and then NFVO can communicate with the WIM, or having the WIM as part of the domain orchestration. Think of a network domain controller or network orchestrator. I'm giving an example from the market, just from my experience. Let's say, for example, the NSO, the Cisco product, and then NSO can go directly and communicate with the networking fabric or networking part or networking devices of Cisco or whatever vendor to realize the connectivity. And in that case, when you want to provision the service, a higher orchestrator will talk to the NFVO to realize the cloud part, and talk to the WIM to realize the networking part. Also in release 4, the concept of OR was introduced. The integration between two NFVOs exists. And why it existed? Because by that time, many operators, they wanted to introduce a new NFVO beside the existing one. We say it's a brownfield environment. For administrative reasons, for whatever use case. So there was no framework that allowed the integration between two orchestrators. So that was realized in R4 to have the capability that two NFVOs can communicate together. I'll stop here. I'll take a question and I'll go to release 5, because I know release 5 has a very interesting stuff related to containers. So I will stop here and take the questions, and then I'll continue with R5. I have a question from Ahmad Khadr. Is there actual use case where the VNF manager can integrate with OSS BSS? So this is the question. Again, I will take it from a telco mindset. So the telco mindset here says, okay, apparently there is no use case because the standard is not saying that. And so the answer is no. But if I answer that from like a modern mindset, I would say yes, why not? I would say if you give the space and like if you ask your developers or your team to innovate, yes, maybe they would come with a use case that OSS system, whatever OSS system, can integrate with the VNFM. So yes, there might be a use case if you open the door for the innovation, but as long as you are strict to a certain reference architecture, so you will not find use cases. So the answer is yes, there are use cases if you give people space to think about use cases. So I hope I answered that. And then a question. What is your opinion on the reason that any telco vendor prefer to deliver VNFs on their proprietary cloud rather than third-party cloud? Is it commercial reason or is they fear from any technical compliance deviation? So this is a very good question, and I will answer that. Try it in a quick way. So usually the telco vendor, he is providing for application, right? He's originally coming from application perspective, from network function perspective, and he's actually here in the deal because somehow he got a deal or he won an RFP about the application. And in the level of application, there are many KPIs mandated on him, and there are many penalties mandated on him if any kind of performance is violated, if kind of reliability is touched. So he will be he will get penalties, right? So he has very sensitive that he risk these KPIs and these performance figures if being placed on a, I would say, a horizontal cloud platform or a vendor agnostic cloud platform. Why? Because he did the benchmarking and he did like the full testing of his application based on his cloud stack. So 100% he will always push in a positive way to put his application on his cloud stack, just to guarantee that he will fulfill the SLAs and the requirements. The second thing that he doesn't want to put many variables outside his hand. For example, if there's an issue in the cloud, then you have to go to the cloud provider to see what is the issue. Also, the root cause analysis from his point of view will be very complicated if you put multiple layers before the cloud that doesn't belong to his domain. So there are many motivations from the vendor perspective to go for his particular stack. Also, whenever there's a technology evolution like 5G, the whole focus of the vendor will be to develop the 5G features and 5G capabilities. So they don't put many focus or much focus on certification on other cloud providers. That's why you always find that in the first wave in any technology, for example, virtualization or cloudification, usually the preference from the telco vendors is always to put their application on their stack. So I hope I answered that. One quick question. So NFV is focused on cloud scenario. We could use it for core and also radio access. The answer is yes. The answer is yes, because actually these are the use cases for the NFV, the core and radio, these kind of things. So yes. Why there's a requirement of WIM? So the WIM from ETSI perspective, that's the like data center controller that will be able to do the inter DC connectivity. The problem in the WIM, for example, that it is only interested or working on the intra DC networking, but it, for example, OpenStack cannot configure inter DC tunnel or whatever. So WIM is like a higher umbrella of networking. Let's now go. Okay, yeah, shouldn't SDN do the part of WIM? Yes, WIM actually particularly is an SDN, but it's a higher capability. Like it's not just an intra DC SDN, but it's an SDN with a higher capability. Okay, so let's go to release 5. Just we don't want to lose the momentum. So okay, so when release 5 came, and sorry, when release 4 came, that was somehow long anticipated by the community, because release 4, if we're talking about 2018, 2020, that is actually the rise of the 5G and the commercial adoption of the 5G. So by that time, many VNFs or many 5G core functions has become containerized. So there was somehow a gray area. How can we entertain? How can we welcome these containerized workloads where the former ETSI NFV release 3 doesn't have anything related to containers? So the architecture evolves, but as you see, it got little bit or more complicated, and new functional blocks has been introduced, something like the SISM or the CISM, and that's a container infrastructure service management, and that maps to the concept of Kubernetes like solutions like OpenShift, like Tanzo, like Rancher, like whatever doing Kubernetes management or Kubernetes orchestration. And then the CIS cluster management, the CCM, and that's mapped somehow to the multi-cluster manager, for example, something like the advanced cluster management at Red Hat portfolio. So you see that the architecture gave options. For example, NFVO can integrate to SISM, VNFM can integrate to SISM, NFVO can integrate to CCM, and CCM can integrate to SISM. So usually when you give Telco community options, they get confused because we didn't have the concept of options in the standard in the 3GPP. So 3GPP says this is how it should work. So when they come with gray areas or with options, this makes gray areas at the Telco mindset. So this is also one of the factors that I would say decreased or the adoption or somehow put some obstacles in telcos adopting a full architecture like what ETSI NFV is proposing in release 4. The CIR, or that's the image registry, like for example, Quay, for example, that's where you host the container images. And then we had some also new terms related to the descriptors like the MCIO, and this is, for example, like the VNFD, and then you have the MCIOP, and that's how you package the similar to the VNF package, and that maps to the Helm charts in the containers domain. So that was the evolution to cope or to handle the containers workloads. But the question is now actually, is this like highly adopted? Yes or no? This is the question that we may assess. The problem number one, that the standards came in a little bit late stage, and like before having this kind of standards, many operators started to host containerized workloads. So most of them have already that box Kubernetes like, which is a SISM. Okay, so the question is, and I always get this question from all the customers: shall we integrate the Kubernetes with VNFM? Or shall we do the integration with NFVO? Or shall we group multiple clusters or multiple Kubernetes instances with a container orchestrator like CCM, and then CCM integrate to NFVO? Or shall we integrate that multi-cluster orchestrator with the domain orchestrator and the OSS? So my answer is and will always be, we need to stop thinking in the legacy way. We need to stop drawing reference architectures and asking what is the northbound, what is southbound. Let's all go to a service-based architecture, have all these blocks producing services on a message bus or a service bus or whatever, and then see what is the needed use case. If the needed use case that a certain product X consume a service from product Y, then that's it. Do the integration and do the testing. But don't do the integration for the sake of integration to realize a reference architecture. You will spend money and effort without use case. So have a use case, build a modern and agile architecture that allow any functional block to consume services from any other functional block, and you will have this kind of lean architecture, and then you most probably all the use cases will just need some sort of development, and that's it. Okay, I will stop here and and then I'll talk about some selected features. I know this topic attracts the attention of many of the colleagues. So one question about where ETSI MEC platform can be located with this evolution. So the MEC, which is the mobile edge computing. So ETSI MEC, it's another ISG industry specification group in parallel to ETSI NFV. So most of the enhancements or the contribution of ETSI NFV to the MEC, you will find it on the MEC publications. Okay, but the idea is actually that the concept that you have been able to enforce in the regional and national DCs based on ETSI NFV is still applicable to the edge. Why can't we see middleware layer in NFVI commonly? What its significance on NFVI? The concept was not there in the telco mindset, but when we go to service-based architecture and based on what I'm saying that all services, all functional blocks should expose capabilities, the concept of middleware will be applicable. That if you treat the architecture like that, yes, it's very common that you have a middleware that similar to any software architecture. But with the current mindset and with the current blocks, there was no, I would say, explicit need to have a middleware in such architecture. Okay, one question. Regarding Vim, my understanding that it will be used to manage two sites as an example. Is that correct? Shouldn't we consider managing two sites with one Vim or at a single point of failure? Well, commonly, if you have two data centers or two sites, I'm talking about the telco deployments, you have two Vims. The request was there that having one Vim managing two remote environments on two distinct DCs, but the common deployment is to have two Vims managing two environments in two separate data centers. And that's where you find the products from the supplier that have like multi-Vims instances manager centralized. So having one Vim managing two DCs is not that common. So if I talk about the WIM, yes, the WIM, it's one centralized instance, maybe with a DR capability that can manage multiple DCs. Okay, one question about, are the new interfaces released, has any commercial implementation nowadays or not yet? I would say really you can find someone or a deployment that is actually adapting to the architecture and live. So maybe ongoing, there are some trials to do such integration, but there is nothing live. But from at least infrastructure, from application perspective, yes, there are many commercial references with containerized applications and container orchestration. Okay, so I will skip the other questions, sorry, for the sake of time, and I will plug that offline. So let's go back to the features. So I will spot on some features on release 4. So from release 4, there were some features carried from release 3. One of them that I'm pointing here is cloud native VNFs and container infrastructure management. And here you have to acknowledge how ETSI is writing the terms. So it's called cloud native VNFs. Most of the market is not using that term, right? Most of the market using cloud native functions, CNFs, to denote that CNFs is the evolution of VNFs, okay? But the mindset is different, and I understand what is the background, but they are using the term cloud native VNFs. And cloud native VNFs, this might map to the containerized workload that we are having currently in that phase. So you see in the right hand side, that's how you do the modeling for the artifact in the VNF package. For example, the VNF descriptor that we used to in the ETSI NFV infrastructure as a service stuff that has a VDU connection point. So there are some new attributes that define or do the modeling for, to the container, and that at the end maps to the what we see in the Helm charts. For example, you see, for example, I'll just move my video from here. So the concept of namespace would be like tenant. The concept of VNF component is mapped to the OS container. So there was some trial to do the modeling or to import the new container constructs or attributes in the existing VNF descriptor or the existing packaging of the ETSI NFV. So you'll get these deliverables in the IFA 40. So that's stage 1 or 2 if you want to know the information model, this kind of relations between the attributes like OS container image, VNF package, that's in IFA 40. And then SOL 001, that's where you get the exact structure of the VNF descriptor. So the new containerized paradigm or container paradigm attributes are fed into SOL 001 to provide an enhanced VNF descriptor. So if you want to see that, you go to SOL 001, and that's the stage 3. From security management and from architecture perspective, in R3, there was the introduction of the idea of security manager, and that has been a request from many customers to have some sort of a security orchestrator. So that security manager that actually define security policies and enforce security policies and have integration with the NFVO and the VNFM and the Vim. So you can get this kind of logic and information model and data exchange or information exchange in IFA 033. So whether this is achieved or not, I haven't seen that highly adopted in the community, but it is there as one of the publications of ETSI NFV. Maybe it's worth to be tested and verified by the operators, but it was there in release 3 and carried to release 4. Something that's very interesting for me, and sometimes you need to do an upgrade to your network or a change to your mono structure. ETSI NFV never talked about that part. For example, I'm bringing just a screenshot from the publications. For example, if you have a specific VNFM managing a certain VNF, and then you want to go to a generic VNFM strategy, like you have one unified VNFM that manage multiple VNFs, instead of having a specific VNFM from each VNF provider or VNF vendor. So this kind of transition or upgrades are now being covered in release 4. But if you see the publication, and if you remember my talk about the stages in standards, we only have a GR, a group report, and that's a stage 1, sometimes referred to stage 0. So it is just a report, like the use cases, what are the options, what are the choices that we have. Usually after this kind of document is solidified, it turns to be an IFA or a stage 2. So currently we have some ideas as a NFV REL 011 or a report to also provide a framework for this kind of upgrades and this kind of mono change. The new features, and you now understand the mentality on how ETSI NFV tries to cope with the evolution of technology. For example, there is a new feature called the new enhancement for 5G. And people who are working on the containerized workloads, you know, the need, for example, to have an external load balancer, you need to have somehow our DNS capabilities on the network. So ETSI NFV now is assessing these kind of scenarios and trying to position solutions, and that will be the contribution of NFV in 5G. That's just an example. There are other use cases. So if you go, for example, to ISFA 037, you will find these kind of use cases and the assessment of these use cases in a form of a general or group report. So that's a stage 1. And you see the scope is actually support deploy 5G network capabilities, the relationship with NFV, and somehow profiling the NFV deployment to support the 5G deployment. So ETSI NFV is trying to cope with the new technologies and provide solutions from cloud perspective. Last one from release 4, and then I'll take questions. The idea of actually bringing more innovative techniques and making smart decisions in the mono framework. So, for example, working on the closed loop automation. So people working on the OSS, they know what is closed loop automation. Closed loop automation is just like a closed loop when you execute a change and then you monitor that change, and then when you get some sort of observation, like a degradation in performance, any kind of error, any kind of SNMP, any kind of feedback, you do an analysis, and based on that analysis, you do a corrective actions, and you re-execute again. So this kind of closed loop control or closed loop automation is being assessed in one of the group reports now, IFA 041, and it's meant to support or the NFV manual to manage autonomous networks. So you don't need to statically define the policies, but you can just enforce the closed loop control and bringing more and more automation to the NFV manual. So that's our four just selected features. I will stop here and get some questions and then move to R5. Okay, so I'll take two questions. First one from Ravi Kumar. So the question is, most of the telcos are managing separate NFV CNF platform, and seems to be they are spending on CNF evolution. Do we see release 5 hybrid reference architecture shall be realized soon? Yes, exactly. Your observation is completely right. So most of the telecom operators have a brownfield environment of OpenStack or VMware or whatever infrastructure as service cloud. And then when they had the decision to go to 5G and embrace the containers, I would say, framework, they decided to go as a greenfield to build a new stack for containers. And this is a wise question because there are a lot of issues in the old stack, so they want to start neat and clean. Okay, so yes, the strategy now is actually to go to hybrid architecture. But how to go to hybrid architecture? Most of them, they have a strategy that many of the VNFs, virtual network functions, or based on infrastructure as a service, they actually work with the vendors to build a roadmap to be containerized and then do a migration program to migrate all the infrastructure as a service workloads or the VNFs into CNFs. So gradually these VNFs will be moving to the CNFs, and the rest of the VNF that will remain still in the infrastructure as a service. Most of the containers platform now, they are providing a hybrid stack that actually can manage containers and manage VM-based workloads. So most probably eventually they will all settle on that platform. If not, then we will have, I would say, and that's a fact, a small silo of the virtualized network function that cannot be modernized to go to CNF, or for some reasons they are not migrated to the hybrid platform. And that also answered the second question about, do we have a standard strategy moving from OpenStack to Kubernetes? Yes, most of the operators have a modernization strategy together with their partners to go from not from OpenStack, but from virtualized VM-based workloads to containerized workloads. I will leave the other questions for the offline. Sorry, I see only the Q&A. I don't see the chat. I see some points in the chat, but I see the Q&A. So let's move forward and see the R5, which is actually not yet closed. So it is interesting to see what ETSI NFV thinking about and what are the new features. So one of the features that I personally had a desire to have this feature like 3 years back, because from operational perspective, we had some requirements from many customers to have a multi-tenancy for NFV model, that you have one instance of orchestration, for example, but for some reasons there are some many other departments or some other teams that want to utilize the product, but they need to maintain their own tenant. Okay, and by that time some orchestration solution had this kind of solution, but it was like a vendor specific solution. But starting from release 5, ETSI NFV is assessing to provide a framework for multi-tenancy, that yes, you can have one NFVO, for example, but you can have an NFV mono multiple tenant, like 1 and 2, to have like tenancy in the orchestration, so that, for example, multiple teams or multiple departments, they can have some sort of virtual isolated environments within one orchestration framework, and even that applies to VNFM and to the infrastructure as well. So it's a nice feature, and again, me personally, I explored that ask and that requirement from many customers. My favorite feature, and this is what I was talking about in the beginning of the webinar, service-based architecture for NFV Mono. That Mono framework should be treated from a service perspective. That we move the reference architecture, we move the Mono DNA and integration points to a service-based. And if you do that, and I will just point to the last point, to the last, I would say, bullet in the scope, you can just enable new consumers. Like, it's not mandatory that whoever consume the API of the VNFM is to be the NFVO. You can have whatever consumer that you can, as long as there is a use case to add more consumer, just add it. And that's why, for example, policy engines, license manager, AI-based system, etc., can be a consumer for the Mono capabilities. Me personally, I'm a big fan. I'm pro this feature. I hope it sees the light. I hope it helps to change the mindset that we just don't want to follow the reference architecture for the sake of reference architecture. We need to build an architecture that fulfill the use cases that we have, maybe from business perspective, from technology perspective, but at the end, moving forward with a very complex reference architecture is still a telco practice, a classic telco practice. We need to move into the service-based architecture mentality, and we all saw how 5G came with that concept of telco. So now, when you draw the 5G architecture, you draw the service-based architecture, right? So anyone can consume service from anyone. So it's a good thing that this is being now assessed in release 5, carried from release 4, and that's the name of the report, IFA 039. Just, I think it's worth that you check it. Continuing the evolution and continuing the mentality of ETSI NFV that trying to cope with the new technologies. So there is a new feature or working item, which is the NFV for vRAN. So they analyze the vRAN use cases, synchronizing with many standardization bodies like the TIP and the ORAN Alliance and whatever, and see how can NFV contribute to the ORAN architecture. You know that ORAN has a concept of OCloud, Open Cloud, which is 100% maps to the concept of NFVI and container application orchestration and the Vim and these kind of things. And the SMO, which is the management and orchestration, service management and orchestration, which maps to the Mono part, for example, in the NFM and the NFVO from ETSI perspective. So there is currently an assessment on how ETSI NFV can contribute and NFV can contribute. But again, this is one of the issues that this might be a little bit late move, because the other technology has been evolving, embracing other cloud initiatives, welcoming and providing solutions for Open RAN, for example, containerized CU and DU. So we believe that this little bit slow move, but again, this is one of the characteristics of the standards. Standardization bodies are moving on a slow pace. That's a classic approach that we have been used to since like the 2G stuff. Because it is an important topic and it is actually trending, the work item green NFV. So now ETSI NFV is assessing the parts related to the energy efficiency. So assessing how can we reduce the power consumption of the whole NFVI components out of the ETSI NFV architecture. So there are some assessments and reports now focusing on the energy aspect of the stack. And most probably there will be some, at the end, published KPIs and metrics and some recommendations on how to reduce the energy consumption and like somehow of best practice from the market to achieve that. So it's a good thing, and the work has started in as a group report in 021. So also it's very good, nice and interesting if anyone is interested in that specific topic to follow the progress of that publication. So most of these are still draft, so not yet closed, but you can always check the ETSI NFV portal. So I'll stop here and then take some questions and then conclude. I hope it was interesting, but let me take one question. There's one question about, would you please clarify again the difference between CNFs and cloud native VNFs? So I'll take the term CNFs, okay? CNFs usually maps to cloud native functions. And to label a certain function with cloud native, there are some characteristics about that kind of network functions. You can find it in many contexts, but as a summary, being lightweight, to be based in containers, based on microservices, aspects related to load balancing. So there are some aspects that actually say that these network functions are cloud native or not. Some domains or some contexts, they map CNFs into containerized network function, which I don't agree, right? Because cloud native functions is more general, and actually one of being cloud native is implicitly being based on containers. What is cloud native virtual network function? That was the name selected by ETSI NFV. So they don't think that virtual network function is a bad name, right? Like it was V, now it is C. No, well, it's still virtualized, but now it is cloud native. So you can think of a network function based on containers as a cloud native VNFs from ETSI perspective, because this is just the mindset. They believe that the word virtual, okay, it's still valid. So it is a virtual, but it is cloud native. So, and also it gives space that if you have a network function based on VM, it's a VM based, it can still be cloud native if it fulfills some criteria. So that's why they have used the term cloud native VNFs. It's a little bit broader term that can map to multiple things, not only one thing being containerized. Okay, I will conclude, and I will gather all the other questions and reply to them offline. We are on time. Thank you for that. So we only have 3 minutes. The key takeaways. It will come right. Yeah. Okay. So the standardization effort is progressing. Yes, every 2 years we have a new release, but the pace is very slow compared to technology evolution. So that's why technology now like is usually in telcos we used to have the standards first and then we develop the technology, but now it is 100% reversed. You get the technology, you get the trials, you get the contribution from the community, and then you start to find, okay, you start to ask where is the standardization. And this is one of the problems with ETSI NFV, that the late pace, I mean, starting from 2018 or 16, maybe, has become very slow. That's why many operators, they do the deployment, you do the architecture, and then the question comes like, is there a standard? Is there a reference? So this is one of the issues. But again, that is one of the characteristics of the standardization, that the cycle itself to produce stage 0 and then stage 1, stage 2, get the approval, and then publish a specification that is not explicitly or to be adopted by everyone. This is the case. Moving to SBA might be a smart move. Yes, 100%. If you want this architecture to be adopted, highly adopted, free the architecture from the complexity. Do not enforce northbound, southbound system. Do not enforce certain consumers. Don't enforce certain producers. Just go to a service-based architecture. Again, everyone can expose service. Everyone can consume service, and based on the use case, you do some development and you realize the use case. Third thing, and that's maybe a surprise for all Telco fellows, that publishing standards only doesn't mandate adoption. Unlike 3GPP in the old days, you do a 2G standards, everyone follow. You do a 3G standards, everyone follow. In software, in cloud environments and cloud deployment and the cloud mentality, it's not like that. Standard doesn't mean anything if there is no code or there is no development effort or there is no API specs. This happened to me personally and happened to us, all of us, when we started to go to OpenStack summits, coming from telco background. So we have requirements, right? We have requirements, we are customers. But we were surprised that the message was clear. If you don't code, don't talk to us. If you are only coming with slides and architecture, don't talk to us. Come to us, be part of the working group, be part of the project group, do the coding, and get the approval from the team members, from the community, and then adopt the project. We all adopt the project. That's why most of the standards body now, like even ETSI and NFV, they are having ETSI OSM, for example, open source manual, that they are trying to develop and code these kind of specs to enforce it, to make it as a de facto open source adopted stuff. So again, it's not just standards, you have to code, you have to be part of open source groups and then enforce it from there. Last thing, telco vendors in particular, big names, they have to collaborate and they have to be open, because the act of having black box integration and mandating that the vertical stack should come from one vendor, this is not acceptable anymore. With the new initiatives like Open RAN, OpenX, OpenY, OpenCore, the openness is now is a trend. So if you are introducing a functional block part of the stack, it must be open. You have either you follow an open source specifications or initiative, or you are eager to share your APIs being open. And also you need to collaborate. You don't need to say I will collaborate with this one and not with that one. You need to have the collaboration culture. If this does not happen, then we will repeat again the cycle of having silos and silos and silos. And then when you have silos, it becomes a hell to unify this kind of clouds. It becomes a hell to consume services in a smart way and start to selling product to the market efficiently. So these are the key takeaways from my side. This topic I've been working on personally, so that's part of my experience in my current work and my previous work, and also my interest being part of some standardization groups. I hope I was able to convey the picture and explain the basis of ETSI NFV and how you interpret the standards, and also shed some light about the evolution in architecture and the evolution in features. So thank you. I will now conclude the the webinar, and I'll stop the recording, and then we'll have like some time to get the questions, if you don't mind. Thank you again, and looking forward to meet you in the next webinar. Now, if you have any comments, any questions, please feel free to ask.